think we're gonna go ahead and get started. So thank you all for coming out to today's mashup. And so I'm Kathleen Denya, if you haven't met me before. So my role for the Plant Sciences Initiative is I'm Director of Innovation Partnerships. In my role, I support industry partnerships for the Plant Sciences Initiative, and then also entrepreneurial efforts. So trying to help get our technologies that we're developing here at the university commercialized and into the hands of farmers. So thank you again so much for coming on out. We have a really great program for today's mashup. So we have two speakers, and we actually have an extra speaker that's going to be starting us off today. I'll introduce him in just a second. So just to remind you, if this is your first, to let you know if this is your first mashup, the whole point behind this is that we want to be able to bring together our industry partners and have them be able to network and interact with our researchers here at the university. So we actually have in the building a location that is a physical spot for these types of interactions between industry and academia. That's up on the third floor of this building. If you haven't been up there, I suggest you, after this, during the networking session, you can go on up and take a look at our Innovation Hub. And so the Innovation Hub is a space where companies that are members any of their employees can come work from that space. So here's our 13 members of the Innovation Hub. So thank you so much to the companies who have joined our Innovation Hub. We really appreciate your support. And so this event, Mashup, is also an opportunity to put the spotlight on one of our industry partners and give them a stage where they can talk to our local ag tech community. So today's company, there we go. Today's company that we're putting the spotlight on is UPL. So we're really happy to have UPL as a partner of the PSI. And we're really happy to have a great speaker, Walter Diaz, here from UPL today. We also have an excellent speaker from NC State, Chris Reber-Horton. So that's the whole point of Mashup is we bring together a speaker from industry, a speaker from NC State. They're each going to give a talk, and then after we'll be able to network. So go to the next slide. Okay. I do want to point out we do have another excellent event coming up shortly. So on April 17th, and if you're not aware of this, go ahead and grab the barcode right now, but it's an event that we're going to hold here in the same spot, and specifically it's going to be on genome editing in crops. If you're not aware, we are very excited that we're actually right about to launch a genome editing center here in the Plant Sciences building. And that's coming along with an endowed professor position. So we actually have gone through the interview process with some excellent candidates. We're down to our chosen candidate, and hopefully we'll be able to make an announcement soon. But this event's going to highlight the work that we're doing here at the university in genome editing in crops. So yeah, April 17th, 3 to 6 here. Hope you can come. All right. So actually, I want to go back to the first slide real fast because I want to give some thanks to the F3 Tech Accelerator Program. They're providing support for this mashup. So thank you so much to F3 Tech. And if you're interested in more information about them, you can approach me after, and I'm happy to share more information about F3 Tech. And so we also have a speaker who's here. So I want to invite on up. Uh-oh. Okay. I'd like to invite up Amir Kenshin. So Amir, thank you so much for coming. And so I know you're a partner with F3 Tech and you're here to represent your group. So
well, actually, thank you. You said the name well, so we're very impressed. I'm here. I don't really know why I'm here. Treasury gave my company about $250 million to do some capital access for the state. And they called me on Tuesday and said, you need to be somewhere on Thursday. And when somebody gives us $250 million, I said, yes, I'll be there. But I'm glad to be here, though. And I think I got 5 hours, Kathleen. So I'll let you guys out. I'll be done by 8:30, I promise. I won't be long, I promise. It's just 5 minutes or less. We have money from the Treasury Department, we being the state. They granted North Carolina this last round $202 million to do capital access for our businesses and entrepreneurs in the state. And what we do is, this is second iteration. We got, I think, maybe 47 million in 2010 or 11, and we use 34 million towards our capital program. And what we do is we work with banks and venture capital firms to help them get capital out to people in the state. So we got, this last time, we got $202 million. There's 5 main programs, and we've only run 3 of them. Now, I'm only going to talk about 2 programs in my time. We run a loan program where we work with the banks to purchase either 5% to 30% of the deal from the bank. And the reason we do that is because most times entrepreneur has a great idea, the business makes sense, they'll have equity payment. They need, say it's $1 million deal, they'll need 10%, 40% to make it work. We work with the bank, we say, let the borrower put in 5%. We'll purchase anywhere from 10% to 30%, so the borrower keep money in their pocket to grow the business. Works out really well. We also have a venture capital program. We have 10 fund managers we work with across the state, and they go out and they find entrepreneurs, early stage startups, and they give them equity to do their business also. It's a really great program. One more program I won't talk about, capital access program, but we take it very seriously. We have about 43 partners across the state. You've got to be less than 500 employees, and your deal has to be 20 million or less to make it work. That's really the only criteria. Primarily community banks, sometimes we do big banks too, primarily community banks, credit unions, CDFIs, venture capital firms, and the whole goal is to help you get capital for your business. It works really well because, and also we have, this is good for you all to know, NC State, we got $6 million from the federal government to do TA for SBTDC. So the Small Business Technology Development Center, which is based here in NC State campus, they work with borrowers, entrepreneurs, get them ready for capital. This is the real cool part though. We have a leverage program, so we don't really do direct lending, it's indirect lending. And what we do is we provide the bank capital to help you all have less money out of your pocket. So for every dollar that we provide, the bank will put in $6. So we leverage, it can be more than that, but we've leveraged lots of capital. In 1.0, we actually got 34 million for lending. We recycled it 3 times, evergreen, and we actually lent out more than $90 million in capital that leveraged more than $1 billion in private capital finance, which is outstanding. For 2.0, as of now, we've already leveraged, I think, we deployed $114 million in capital. There's leveraged more than $700 million in private capital. And we think because it's evergreen, by the time we're done, we'll have more than almost $3 billion in private capital. So it's a great program. I've got a list of banks and partners that I'll provide to you, Kathleen. I think you guys should check it out. It's really helpful. We've helped dozens and dozens and dozens of companies and businesses all across the state. You've got to be based in North Carolina, have to have fewer than 500 employees, and your deal has to be 20 million or less. Pre-revenue is fine, as well as existing businesses. So startups, expansion, and we do equipment, we do primarily it's owner-occupied commercial real estate, but we do all kinds of things. We do working capital, so anything you've got in terms of pre-revenue, we do. And we've got 0 delinquency, so all of our loans have been paying, all of our investments, we've got a pretty strong internal rate of return, probably around 15%. We don't lend based on return, it's all about mission for us. So we're mission-based. We like returns. We want to get the investments back. We love returns, but we're primarily concerned about mission. So it's an excellent program, a lot of capital. So far, we've leveraged over $700 million, a long ways to go. We have a lot of revenue left, a lot of capital left, so please look it up, Kathleen. I'll send you more information. F3 Tech, I'm not sure if they're here or not, but I'm not with F3 Tech. It says they're here, but I'm not. But we will certainly provide more information for you guys to be helpful. But it's a great program. And again, Treasury, I don't know who knows somebody at Treasury. Is it you? But they called and said, make sure you're there on Thursday. And I said, okay. So I don't know whether it's F3 Tech, NC State, or Kathleen, but they got us here. So it's a great program. You all have any questions, I'll be around for the rest of the day. Hopefully we can connect with you all and help you with the business or your startup.
Thank you so much, Amir. It's really great to hear about the resources that are being provided in North Carolina to support our entrepreneurs. So thank you so much. All right. So now I'm going to switch it over to the main program. And our first speaker, let's see, waiting for behind the scenes, the screen is moving. So, all right. So our first speaker is Walter Diaz with UPL. He's the global head of R&D for UPL. So thank you so much to Walter for coming and speaking.
Hello, everyone. First of all, thank you, Kathleen, and Adrian, to invite UPL, in my person, to be here to talk a little bit about UPL as a innovation research and development company. Okay, the idea for today is to talk a little bit how we are doing this here in our innovation center and also around the world, and explain a little bit how can we partnership with some initiatives that we have here in universities, startups, and so on. Okay. And then I want to introduce myself. I'm Walter Diaz. I'm from Brazil. I'm working in UPL now for 4.5 years, but I'm in this business for 22 years now. I worked for other companies in the past, but always in product development, business development, and market development, always trying to use the technical data to support business. Okay. So I moved here to the US last year. Again, I used to live here in the past for another company, and I moved back to Brazil, and I moved here again. So the idea is to support UPL to build an innovation research and development structure here in our innovation center that I will talk a little bit more in a few minutes here. Okay? So talk a little bit about UPL first. UPL was born in India 56 years ago. Yeah, UPL has 56 years and was born in India, but nowadays is in more than 138 countries. It means that we are doing business in these countries. So grow a lot. UPL as an agricultural company. UPL has more than 10,000 employees around the world. More than have 44 factories to produce the products that the quality and to ensure the quality that the products that came from UPL has. And also we have 18 R&D innovation center. It means we have one here in RTP, and we have our research stations, and also we have some formulation labs and something like this in India, in Brazil, and around the world. I will explain a little bit here. So before I start, I wanna talk a little bit about the one concept that we have in UPL that is OpenAg. You know, in all the brands that you see UPL, and then you see OpenAg. What is OpenAg in UPL? It's an open network of agriculture. We work with partnership. When you talk about, I will talk a little bit more about research and development, but these apply for all the areas that we have in UPL. We are open to discuss, to do partnership with universities, startups, big companies, Japanese companies, Chinese companies, doesn't matter the origin of the company, but we are open to do these kind of things. And our focus is to bring to the business, to the growers, innovative solutions for crop protection. And crop protection for us is an association of conventional chemistry plus biologicals. Always, we really believe that the two kind of products together will solve the growers' problem. Okay, so talk a little bit more about our OpenAg research and development. We focus in 3 pillars, mainly 3 pillars, simple pillars that you have. The first one is the grower problems. The grower is needed. We need to make sure that any investment that we are doing in innovation, research, and development is aligned with to solve some problems in the grower level. The second one is we invest in technology and people. We need the right people to manage our pipeline, to do the right trials, to do the right research, and have the right data to help us to make decisions in our projects and move on in the development phase. And the third one, as I already mentioned here, it's a collaboration through OpenAg. OpenAg, it's a concept that we have in whole company, but in R&D means co-creation. We are open to discuss, for example, if you here in the NC state, you have some new technology that you guys want to develop this, we are open to discuss how can we do it in a partnership, in co-development. Yeah, this is our OpenAg concept that we have in UPL. And talk more in a little bit more in detail how we do it. Yeah, this is our footprint around the world. If you see here, we have our global OpenAg R&D center here in RTP. where we have our experts. We have some experts for weed science, some experts for entomology, plant physiology, and plant pathology, where we have some facilities, lab facilities, and also some greenhouse there, where we can do some trials using agile methodology to have some agile results. We just to, for example, if somebody came to us and say, "Oh, I have a nice product, biological chemistry, mixture, new formulation, doesn't matter the kind of product, and this is aligned with some our strategy." We can do some trials there to make sure that this works, and then discuss in the company if it makes sense to invest more or not. In the case that we do some trials there and works very well, we have our research stations around the world. We call research station network. We have one there in Vietnam, one in Indonesia, two in India, one in Spain, another in UK, one in Mexico, and one in Brazil. These stations are split based on the business importance that you have and the agriculture importance. And in the case that the technology that we tested here was okay, we send this out to the research station where the business need or the grower need is. For example, if we're looking for some rice technology, we send out this to Asia for the station that we have there, because there we are able to do all the trials. We have some capabilities that is the kind of trial that you can do, and some capacity, how many trials you can do for these kind of things. And to manage this, we have another team here that we call Global OpenAg R&D Product Technical Development. These guys are linked with marketing colleagues. We have one market colleague from UPL here from herbicide. So marketing is responsible for our strategy, and we need to be aligned with them. Every US dollar that we invest here needs to be aligned with our strategy. And these guys, this team, they are responsible to link market and us, and make sure that we are investing in the right way. And then after that, we have some results in the field, because in the research station we have lab, greenhouse, and field trials. The main important is field trial, because there is the environment, everything, weather conditions, it's close to the business. And then we have our business units. UPL has 8 business units around the world. This one in blue here, where we have our local R&D team and also regulatory guys, where we do the final position, technical position, and hand over this to regulatory guys, where we start the regulatory trials, follow the local regulation, and then we move after we submit this to the authorities for evaluation, and we hand over all the technical information to market development and sales. Okay, this is the way. We have a different business model in each region. For example, here in US, we have an R&D team. We work with CROs. The CROs do the trials for us, but we visit, we discuss about this. When you go, for example, for Brazil, we have our own team. We do our own trials there, and we generate our own data. And in Latam, we have a lot of countries there, can vary a lot, from Mexico to Argentina, have a different ways to work. Europe also. But this slide is the way that I want to show you guys our global footprint as a research and development company, UPL. Okay, and also a little bit more information on how we do it. I showed in the map, but it's not unique for UPL. This, I know that most of the companies that work in R&D works like this. We call phase gates. Some companies call stage gates. It doesn't matter the name, but the idea is we need to have some time to sit together and make decisions. This is the phase gate decision that we call. And how many phases? These vary between companies, between business model, but we have 5 here in UPL. We have the phase 1, when any new technology came, we did a kind of characterization, try to understand what kind of technology it is. We look for papers, we look for some results already published, and make some decision, or we do some lab trials to check. Mainly, all the phase 1 technology we do here in our innovation center in RTP. When we move to phase 2A, it's a kind of proof of concept. It's a kind of movement from lab greenhouse to field. It's the first contact we have field, just to make sure that all the results that we had in lab and greenhouse you replicate in field, because in the field that will be applied in the future, if it became a commercial field. And then we move to phase 2B, where we really go to finalize our position. Phase 3 is already regulatory trials, and we submit this to the authorities. This, again, the phase 4 is the time between submission and registration for the new technology or new product formulation. And this varies a lot, depends on the country. For example, we have some countries in Latin America that you can have registration 6 months after submission. And also we have some ones that can take 6 years. This depends a lot. You need to be very close to regulatory trials and be in compliance with all the rules in order to follow this and make sure that in the time that we will have registration, we will be able to launch this and sell, to have revenues, pay the bill, and start to invest again in another technology. Okay? And also important to say, when we have registration, we move to sales, but also as a R&D, we do a kind of lessons learned activity. We look for all the phase gates and check what we did well, what we did wrong. So let's try to not repeat the wrong things, yeah, and repeat not just the good things. And we are in a learning process anytime, all the time. Okay. And also we have here the way that we make decisions in the phase gate. We call as a triangle project management. Here in the triangle, in the 3 sides of the triangle, we have the main areas, not all the areas that are responsible for this, but R&D, regulatory, and strategic markets are the 3 areas that are responsible for the medium and long term inside. When we talk about portfolio management, we are responsible for this. So we used to sit together in all time that we need to make some decisions. Oh, everything is okay in the R&D point of view. If yes, regulatory and also strategic market, we can move on. But in the sides, we can see that we have a whole company. We are not saying that we make some decision in these 3 areas and ignore the other areas of the company. No, everyone important here, but we are responsible to make sure that the things will happen. Just an example, I think you guys have experience on it. Sometimes you have some new technology or some innovation that in the technical point of view makes totally sense. So it's a nice product, can be applied, but maybe you can face some challenge as a regulatory point of view, or even when you go to market KPIs, for example, maybe the cost is not aligned with the pricing points that you have in the business, and or we need to invest a lot in the payback of the project will be not attractive for the company and so on. That's why every time that you have a new idea or the project that we have ongoing, we used to sit together as a triangle, we call here, to make sure that everything is aligned and we can move on with this new technology and have registration and became an innovative product as available for the growers. Because as I mentioned in the beginning, everything that we are doing in UPL is to solve some growers' needs, some growers' problem, because this is the way that we will support agriculture around the world. Okay, and then the last slide that I have here, I have this phrase from a colleague from Brazil that it's just a real innovation if improve the grower's life. Maybe you can think that you have an innovation, but if it's not useful for the grower, for the end user, it's not innovation. Yeah. So that's it that I have for today. Any questions, comments? I'm pretty open after the second presentation. Thanks a lot to invite me, please.
Your phase gate process, at which point do you do field trials and at what scale? When you start the field trials, are they ongoing through?
Yeah, the first field trials start in phase 2A field, just to make sure that the greenhouse and the lab and greenhouse replicate there. And if yes, phase 2B is the phase that we're really investing to have as much as data points that you can have to make decision. 2B is the time that a lot of investment in field trials. Please.
You mentioned that Bill focuses on bringing in biologicals and then their fertilizers. You guys do other types of innovations as well, like non-biological?
Yeah, we work with conventional chemistry, it's the biggest part. We are also invest in biologicals. And in biologicals, we have three lines. One is biocontrol, it can be a bioinsecticide, biofungicide, or bioherbicide. That's really aligning with the chemistries that we have. And also have biofertilizers and biostimulants or growth regulators.
I guess my question was more like, you guys do like robotics, for example, outside of like.
No,
Okay.
we partner with the people to have some idea come to me, we can discuss this. We can, when I mentioned here that the second pillar that I mentioned, technology, is like this. We're talking about what kind of technology can help us to be more assertive in the field condition, to more productive, more effective. In this case, can be a very good example. Yeah, but we do not have a team inside of the company taking care about this. We partner with companies like this.
I know this digital and data management that you have over there. Can you speak to what kind of tools you use and how it contributes to your R&D?
Management.
Digital and data.
We use the conventional one, ARM. Most of the R&D companies use this, and we are discuss with some companies. How can we take the data that we have in ARM and have more friendly and try to use in a better way? This kind of thing. We have too many options. We didn't decide yet. Nowadays, we are using just ARM.
AI or anything like that?
Yeah, we are using.
We have time for more questions if there's any more.
So in order to run an operation like this, if you were wanting to start from scratch, let's say, what sort of percentage of R&D investment compared to revenue would you expect?
Very good question. So I think in this level, we work like this. In an innovation center like we have here, we need to be able to manage our expectation, frustration like this, because as I said, sometimes we have a very good project that's producing a technical point of view, works very well, but in opposite. We can do registration, we can make money, but technical point of view doesn't make sense. And also, about the percentage of the revenue, it's depends on the segment that. Not an easy answer this to have here.
And a startup partners with UPL, for example. Does UPL take a equity percentage of the startup company, or are there other ways as well?
We have different models, business model. Depends what the startup is asking for. And also, one thing that we do, because we have this kind of innovation center here, we do not pay any amounts because we have some business model. They came to us and say, I have these, I already did some trials. I want to have some amount of money in order you to be able to test this. We trust each other, but we need to have our trials and try to understand how is the performance of these in our conditions there, and then we can discuss the data together. But depends on the business model. But we can do it. We already have some companies that we work in.
Walter, I have a big question for you.
Oh.
You showed that UPL's looking globally at all of these different agricultural systems and that you're focused on farmers' pain points. Could you like summarize, if you looked across the world, are there common pain points that you're seeing from region to region to region, from crop to crop to crop? And how does that then translate into UPL's kind of global approach to developing new products?
Yeah, so we, as I mentioned, we have some business units there. They are responsible to supply us what is the pain point, what are the pain points. And for example, if you go to Brazil, the pain point, we have a lot of pain points, but our focus mainly, I think all the companies have focus in soybean disease control there due to the business, the size of the business. But herbicides became a huge market because glyphosate is not playing as was in the past. So we have a lot of opportunities. Here, when you come here, you have a big opportunity when you talk about herbicide. When you go to Latin America, is a different business that you can play different games there in order to be successful. Europe is the same. Asia, we are talking about great rice, but we have mapped these kind of things.
I was curious, for instance, if like weed control, you're seeing it in the need for herbicides, you're seeing it in every geography across the world, or are there other things like that?
Yes, I think this, in my opinion, Adrian, this has changed a lot. In the past, we used to have, for example, one product that you can apply around the world. For example, a fungicide for cereals in Europe, in Brazil, and also here in US. Nowadays, I think agriculture is becoming customized. We have some big problems in Brazil, another problem in Argentina, that maybe one technology cannot solve this. But we have mapped, we try, as a company, we need to try to have, if you can have one product to solve a problem of 2 or 3 different regions, you'll be very welcome because you can dilute the cost, everything that you need. But in my personal opinion, it's became most difficult to have this kind of things. A big question.
One last question from anybody? Let's see. Oh, nope.
Sorry, I was gonna say, you mentioned, the OpenAg Center here at RTP, a relatively new center, right?
Yeah.
5 years or something like that, right? Can you talk more about what they do there, what kind of science they're doing right now, what kind of projects they have?
Yeah, so as I mentioned, we have 4 categories inside of UPL. First, fungicides, herbicides, insecticides, and we call NPP, that's natural plant protection. Natural plant protection. The NPP is biological, so biocontrol, biofertilizer, and biostimulants. And our project, the project that we have here is based on the regional needs, business units. For example, we have some soybean disease that came from Brazil. We have here under control, regulated everything that we can do some trials here. We talk about weeds. We have the main weeds of US and also something that we can supply the regions with this results. It's based on the regional needs, the kind of projects that we have here. When you go to insects, it's a little bit more difficult because alive can fly, so it's not a easy. Cannot have here, have some limitations. But when we talk about plant physiology, we have a lot of things looking for nutrient use efficiency. How can we have working inside in physiology to support the plants to use better the nutrient that you have your supplied plant? Today we have a little bit, if you look for ongoing here, we have something close to 40 projects there. In this category, we have something around 25 people working in R&D facilities, but also is a North American global market officer.
That one of like the smallest ones compared to the rest. I imagine in India they have the biggest one.
Yeah, it's if you compare with BSF, and then here is a smaller one. We just started.
Let's thank Walter so much for.
All right, so now our NC State speaker for today is Professor Dr. Chris Reberg-Portman. So Chris is a professor in crop and soil science. He's also our platform director here at the PSI for resilient agriculture. So thank you so much, Chris, for giving us a talk.
Thank you for having me. It's a pleasure. Notice I could not seem to pick a title because I don't care about those titles. We have all this new name, like just non-ending scape of names, but I think we're often talking about the same things when we're talking about resiliency or sustainability or even regenerative. I also wanted to talk to you today, actually something I don't do very often, which is like our own lab's growth over the last 10 years and where we've ended up. Because I think it does speak to where PSI sits in this space. And I think it's why we have enjoyed being here so very much, as our lab has grown in weird directions. I used to introduce myself as a field agronomist for many years. Last week, I tried out, I'm a field agronomist, I was a field agronomist for most of my life, but now I'm a software developer. And everyone's like, what? You can say those words inside this building though, and nobody bats an eyelash. So, which is what I really love about the interdisciplinary nature of what we are here at PSI. So I'm going to tell you a little bit about that journey and a little bit about where we see ourselves fitting into sort of the future. And this isn't being recorded, so I'll make lots of prognostications about the future, and hopefully nobody remembers them. But the first part I want to start with is where has agriculture been in terms of the type of technology that we use for like the last 100 years, in my view, and then where are we going to? So I would argue that agriculture, all the innovation over the last 100 years could be broadly categorized as the industrialization process. And when I say that, I don't mean the pejoratives, no, just pejorative of industrial farms. And I'm not trying to weigh into that debate, worthy though it may be. Instead, I'm going to talk about what is the research agenda been. And the research agenda has largely been mechanization. Now we have biotech that fits in a little differently here, but it's actually a combination in the last 30 years of biotech plus mechanization that has allowed the rapid evolution of our agricultural systems. I highlight that because I think that, like many sectors, the industrialization process, first of all, it brings enormous benefits. The number of humans working in agriculture today relative to 100 years ago is just off the charts. You know, it's common for 80 to 90% of humans to be engaged in agriculture. Didn't leave a lot of time for other activities like universities or other things that we enjoy. But it also can come with the downsides, industrialization. We certainly know the environmental consequences in other sectors of the economy, and we certainly see those in agriculture as well. And I think that's the challenge of our time, and something that PSI spends a lot of time on is how do we reintroduce some sustainability, resiliency into the agricultural food production system. We're not going back to 90% of humans engaged in agriculture. So how do we do it with this highly mechanized environment? And one of the answers I want to present today is I say we mechanize a bit more, and we might be able to do something. I also want to abuse the social science literature here, because God only knows if I'm stealing this stuff correctly. But anyway, there's a lot of talk about the knowledge economy out there, and that how, you know, we think about Silicon Valley, we talk about the knowledge economy. But reading through that, I think a lot of the highlights of the knowledge economy are that we have come up with different systems and intelligence that deal with the complexity of different sectors of the economy. And we are able to allow for more diversity than that industrial economy was able to deal with. So I'll back up and draw this out for a second. If we think about that industrial scaling, what is happening is that industry starts to specialize, and here industry being the farmer, starts to specialize because the machinery becomes ever more expensive and ever more capable. So if we think about agriculture today relative to when the westward expansion was happening, right? Westward expansion happens, people are all the ag businesses. They have some livestock, multiple species. They have fruits and veggies. They have grain crops. They have all of it. They're cutting wood and selling it, right? We're doing all of those things. So the level of specialization at that time, 0. Everybody's doing basically the same thing. The farmers I work with today, I work primarily in the big row crops. So here in North Carolina, we're growing corn, soybean, wheat, and sometimes some cotton in that rotation. Now, believe it or not, that's actually quite diverse. In the Midwest, oftentimes you end up with the entire counties where corn and soybeans are the only crops grown whatsoever. That specialization, what's driving that? To me, that is being driven by the mechanization. If your combine costs $1 million and your planters for corn and soybeans cost another $1 million, you add all that up together, you're gonna have to stick to one thing. In my younger naive days, I once suggested to a grower, if he thought about integrating cattle into his operation because there would be soil health benefits. Yeah, the answer was no, and on no uncertain terms. And so, as I learned to understand why, that's a very definite no. So, how do we get around this? Again, that has brought us the sufficiency of labor, but that simplification of our landscape has come with a lot of environmental consequences. So, flip back now to transpose that against the knowledge economy. If you look at the language there that we're often talking about, it's actually trying to use modern, oftentimes computer science, to deal with incredible amounts of complexity. AI is trying to deal with many levels of complexity, create enough real-time awareness to be able to deal with those in a fundamentally new way. So, sorry, social scientists, I'm sure I butchered that. But again, I think that is where our future lies for resiliency. Importantly also, as an extension specialist, I'm half research, half extension, I think about what does that mean for the land-grant mission. We're not a normal university where we just have to make papers. We actually want to impact the world. It's a priority for this institution. It's a priority for plant sciences. And I think there's a fundamental shift that we have to do at the land-grant institutions that is coming about right now. And we used to do all of our little research, and most of my profession has spent the last several decades doing an experiment in a couple locations for a couple of years, and we say, okay, we studied these patients, these soybean plants or what have you, for several years, and this is what we think they do. That is it is a way to generate knowledge, but it's a relatively slow way to generate knowledge. And now with all of the sensing and all of the intelligence we have on our farms, I think a shift is underway to where our experiment stations and our extension system are going to sit in a very fundamentally different place than they have sat in that pipeline. So me as a professor on the Hill will not go out and do a few experiments, generate knowledge, write extension bulletins, deliver those out to the growers. Instead, we will be using the growers' fields themselves as a way to gather data and as a way to figure out new systems of production. We will be using our experiment stations as technology deployment zones where we're looking at how to integrate new technological systems into those on-farm landscapes. And extension will not be there. I mean, remember, extension got started in like the 1860s. We had a largely illiterate farm class at the time, right? And it was the idea of bringing a little bit of book learning out to the masses. But no, now we have incredibly educated farmers on the cutting edge of technology, but they need independent arbitration in this very quickly evolving world, and I think we see extension starting to play that role. So, all right, that was enough of just pontificating. What does that mean for our lab? How have we tried to embrace this vision for the future? One of the things we've done is we shifted from all research station trials to a majority of our work in on-farm trials, and then we started managing on-farm trial networks around the country. Now, we do have some experiment station trials that are in there as well. We haven't quite got to the point where everything can be done on-farm, but we have managed several research networks. This one I'm highlighting here, we call the Precision Sustainable Agriculture Network, which is what we call our lab. To do that, though, has required just a tremendous amount of technology. So when you're doing things at scale, back when I did my work as myself, it was all kept on Excel spreadsheets, the original database, if you will. Now, when you have hundreds of locations simultaneously conducting a protocol, when you have hundreds of thousands of samples flowing into central testing labs, everything we do has a technological edge to it. So technology is revolutionizing research just as much as it is the farm. And our lab now, if you look at what we do, we have a ton of people who just write custom applications for the research endeavor. We have people who work on custom hardware that helps make all of this possible. And wherever possible, we now have a piece of technology measuring the data where the human is using the technology, and less, but never quite eliminating, Kayla, the people out there with scissors cutting plants and trying to stuff them in bags. But I won't go too far into that, but it has led us in strange directions. So for several years in a row, we've run a technology hotline because all of these locations around the country, they have custom protocols and all this technology, and they've got barcodes, this and that. Well, at the end of the day, we still need humans. Machines I haven't got a chatbot that can answer all those questions yet. So we do a lot of support for bringing along our fellow agricultural scientists around the country to do these common protocols. I'll give you an example here of the payoff for what it can buy, because it is certainly a lot of consternation. This is a protocol for watching residue rot in the field. There's probably a fancier way of saying that. But we do a lot of work with cover crops, and we have one of our decision support tools for farmers that we have is a model that estimates the nitrogen released from a cover crop at any point in time over the summer, so that growers can reduce their nitrogen applications in accordance with that. And so it's an environmental application that has seen a lot of use, but to do this and do this with confidence at scale, we really got to validate the heck out of that. And that's part of the problem with biology is what does it depend on? It depends on the soil, it depends on the weather, it depends on yada, 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 a million things. Again, the reason we got into this work, you can't study that when you do it at a couple places in your in your state. You have to have the breadth and the scale to be able to study those phenomena. So this is one example of a protocol where, what do you say, Kayla? How many tens of thousands of bags have you seen processed through our lab that came out of this experiment over the years? It's a whole lot. But the value is now that we have a model that this decision support tool is built around that has been validated across all of those ranges. And in fact, it doesn't matter. We found that the model that we had built into our tool was failing parts of the country because of humidity. Turns out the modelers had it wrong. Humidity in the early morning changes the amount of dew set, changes the amount of degradation that occurs in some states in enough to really matter. So only when you're doing science at scale like that are you going to discover those phenomenon. I will, if anybody, I'm running behind time, so if anybody wants to explore that that decision support tool, I invite you to click on it there and you can take a look. But I also use this example. We have a whole suite of applications that we have built for farmers, but I highlight this one because it highlights the next major part of our lab now, which is computer vision. So when we built this application, we built one thing into it that the growers absolutely hate. They go out there with a hula hoop and they have to cut their cover crop and put it in a bag and ship it to us. And we weigh it for them and we run it through a forage analysis. The number of growers who want to get out there with a hula hoop and a pair of scissors to cut biomass is vanishingly small. So they'll usually do it for the first few years they use it, then they start eyeballing what they got out there. What we really need is a way to technologically estimate cover crop biomass out there. So we do have that now. If you actually if you go to that website, you type in develop before that, you'll see the satellite version of this tool is staged and will be released in the next couple of months. And so now, instead of saying there's a hula hoop representing cover crop growth in that field, we now have a pixelated map of the cover crop growth in that field based on satellite imagery. Unfortunately, it only works on monocultures. So you see here in this example here where we have a cereal rye field, it can do a decent job of dealing for that differential growth here that's happening. So now we have some more localized intelligence to build off of. But the federal government has chosen to subsidize mixtures for the last 15 years. So most of the fields these days will have like 2 or 3 legume species, some brassicas, some grasses, God knows what in them. Doesn't work worth a darn on that. And so that is what originally got us into computer vision, which is, again, how I got into this weird statement of agronomist, software developer. So I was on tour after my sabbatical, and I had really been reading about machine learning and what it might do for us in the ag sciences. And then I worked through that whole damn. Remember the original machine learning book that everybody called the Bible? I worked all the way through it. You know, you get really bored on sabbatical after a while. And then I was in Denmark, and so I knew that we could do something with it, but I didn't know what we could do with it really. And when I was in Denmark, I saw a group out there that were driving an ATV like 50 miles an hour across these hayfields, and they had a camera strapped to the back, and you could see it flashing. And I said, "What are they doing out there?" And what they were doing out there is they were mapping the species composition of a hayfield at 50 miles an hour, and using that to estimate every bale of hay coming off of that field as to the nutritional quality of it. It's a remarkable achievement. It's still kind of stunning. I also learned about, I was wondering, because I knew enough to be dangerous at that point in time, how on earth were they labeling or, quote, annotating those images to train an AI to do this? So if you're not familiar with computer vision or ML work, the biggest hassle is annotating imagery. So if this scene right here, or this scene right here, that's what real ag scenes look like, right? They are often mixtures of species all growing higgledy-piggledy together, and separating that out is nigh impossible. No human can sit here with a mouse and a cursor and try to identify every little plant part assigned to a species class. Or if you did, maybe it'd take you, 3 days, and then you're ready for the next one. Well, we need tens of thousands of these images to train an AI, if not more. And so the only way that's possible to do that is what we call a synthetic image approach, where we actually make fake images. And so if anybody's curious as to what that robot out the north end of the building is doing, it's the starting point for synthetic image pipeline. You have Mark to thank for the robot over here, rapidly iterating upon. And I'll describe to you a little bit about how that works, because I think this is sort of a fundamental process that's going to be part of computer vision in agriculture. I think as the computer vision community evolves, synthetic image pipelines are still a niche part of it, but there's some parts of the computer vision world where it is becoming dominant. And I think in agriculture, we're going to see that it is becoming dominant. So that little robot out there, we actually have one in Maryland. This is the one in Maryland, and one in Texas. And so they're, in theory, running as much as we are here. And what we do is we take all these different plant species, be they crops, be they cover crops, or be they weeds, anything that might appear in the agricultural landscape, and we take a whole lot of pictures of them. We take a whole lot of pictures because, again, it takes a whole lot of pictures to train AI. We take a whole lot of pictures, too, because biology is messy. I envy those car people, right? A stop sign looks the same no matter where you're at. A pigweed does not look the same no matter where you're at. So when we train AIs to do plant species mapping, we have to take a picture of not one. Our target is 350 individuals from any species we see, so that we can represent the full plasticity of what that species is capable of. But if you're curious as to why we use a robot, is again, remember that annotation process. In an annotation process, a human being has to go and outline everything that is the plant and identify the species. Our goal is that no human has to do anything in this pipeline, and it is by and large there. So when we take these images, we know which plant is in there because we seeded them up into those pods. And then we use a variety of techniques to mask out everything that is not a member of that species. So here you see, or actually, and weird, the AI world is getting weird, and oftentimes in the pipelines of training new AIs, you have AIs that help train the new AIs, that you can get layers deep in the AI. We actually use an AI approach to actually sort of crop out everything that isn't part of that weed, get it down to its barest essentials. So you have just this, which we call our virtual assets, a single plant species, completely outlined, nothing else in that. We do spin it around. It's part of the augmentation process. Spin it this way, that way, shine the lights on it in different ways in an artificial fake way, and then you start building your fake images. So you can see the little gift there. We have dozens and dozens of soil backgrounds, and we started assembling these synthetic images out of all the species specific to a target you might have. So like right now, this one is simulating we're building a weed mapper application for the US soybean board. And so we want all the major weed species in there that might grow in a soybean field in North America. This is another fake image that we've made here. And the beauty of creating this fake image that way is, again, every single little pixel in that image now has been labeled because it's fake. And we knew what it was when we stuck it in there. Sadly, the scissors still have to come out. In a lot of what we do for species mapping for our different applications, we have to know not just what species or what pixel in the picture, we need to know the biomass. Plants are still things we need to know how much of them there are, and photography doesn't directly give you that unless we have some correlation with biomass. So we still have, I think 20 states participated last year in scissors and custom camera and application from us just to gather that calibration data. The expense of calibration data in our field is just massive, but whatever. I think, and I hope the applications will justify the immense pain that it is. So this is one of the sprayers we have outfitted for the Chesapeake Bay region this year. Well, one of the ways we're taking this, this newest application to market is we're actually, instead of going directly to the farmers, we're going through to custom applicators. So if you're not familiar with ag, farmers have all the equipment to do all the farming they need, but they are so large at this point, oftentimes they run out of logistical time for their machinery. And so they will hire custom applicators to come and fill in the gaps in their spraying, oftentimes in their sort of planting spraying schedule, sometimes in their harvesting schedule as well. They'll use these customs to come in and fill in the gaps. So we have 10 of these sprayers in the Chesapeake Bay region now outfitted with our camera system that is taking an image about every 20 feet as you go down the field and about every 20 feet as you go across the boom. And what we are mapping is, again, multiple species of cover crops all growing together in a big old mass. Here's an early season picture where you can see the AI teasing them apart here. And what it is doing when they terminate their cover crops is giving us a biomass estimate of every one of those species. Then we run it through the model over time, and every day we run the model. And when the grower goes out to side dress their nitrogen application, it says this pixel needs 40 pounds less, the next pixel needs the full load, the next pixel needs 20 pounds less. So it is part of the green payments. Supposedly the federal government is paying the farmers and the custom applicators to participate. You may have heard it's a little crazy in DC right now. So we're actually not going to get their payments until next year, but surprisingly, a lot of the custom applicators and farmers decided to go ahead and use the technology. They wanted to see what it would do. Not sure they're going to reduce their nitrogen applications without the payment, but nonetheless, the technology is getting its full run this year. And so what we hand back to the growers is something that looks like that, which is just sort of a plus minus map. This was your nitrogen map. When you gave it to us, this is what we were telling you to adjust it on based on output from the AI. And then lastly, I want to, as I started with that big picture, by the way, Adrian, I really did that for you because one of the things I watch you, I have a tendency to always start in the middle. I'm not a big picture guy, and I love your big picture starts. So I'm like, let's start at the beginning. I thought about the 8 in 2001: A Space Odyssey, and I know that's too far back. That's why I started with like the last 100 years. But to get back to my theme, I just lobbed a lot out of you. But what is it that I think is the future, and why are we investing so much in computer vision and these intelligence systems? So here's what I'm going to put on record as predicting. I would say for the next 15 years, most of our intelligence, at least with the big row crops that I'm dealing with, is going to be on the equipment that we currently use. So we're by and large going to be out there with big old tractors, big old combines, and big old sprayers, and we're going to start strapping cameras everywhere to them, and we're going to use that to acquire enough intelligence to help make the next decision that's going to happen in the agricultural landscape. But the robots are coming for us. They're starting with the specialty crops, they're starting with the high end where they can innovate there, but then the robots will be replacing all of that large equipment. And back to my resiliency sort of environmental win on that, I think there's an enormous win out of that, because when I look across our agricultural landscape, This is the North Carolina I knew growing up here. And I show this picture and all the young people are like, what are we looking at here? Because they've never seen this. The entirety of the Piedmont of North Carolina was in narrow strip crops. It's because we didn't have no-till yet. And so the then Soil Conservation Service had come through and helped every grower develop these contours, and then you would farm in these little narrow strips, and you'd put your corn and your beans and your cotton in those little narrow strips, and then you'd have a perennial downhill from that, and then you go back to your annual crop to prevent the soil erosion from occurring. It was lovely. A 30-foot combine head does not drive a landscape that looks like that. That's also why the farmer, when you try to suggest the cattle to them, they are not going back to driving around fences, right? That's a non-starter. That's why we used to have all these cattle out east. We don't have them anymore. So that simplification of the landscape is primarily machinery driven. When the robots come for us in the big row crop, those kinds of landscapes are back on the table, right? And so I think what our lab's goal is, maybe I retire before the robots take over, but let's get the intelligence and the intervening tier, the cameras everywhere, and make the most of it and prepare for that robotic future and prepare for it to be an more environmentally friendly future. I think it's not a given that has to be an outcome of our robotic future, but it can be one if we make it one. All right, I better stop there. I've gone on too long already.
Maybe 2 questions?
Okay, so as you envision it, let's say in the future you have your outfitted implement and it's identifying weeds as it goes, right?
Yeah.
It's okay, so it's real time. And do you think, because as I understand it, when you take those like series of pictures as you're moving, you can get structure from motion.
Yeah.
And so that said, like, can we still have structure from are we implementing structure from motion if we're having this like real time weed identification in the field?
Yeah, well, that's a great question. The structure for motion can be computationally expensive, and so it can be hard to do that for a real-time thing right now. So generally, yeah, it's not. Now, I will say, like, I'm convinced that 9 out of 10 current ag techs in Silicon Valley are all about weed control. I think it's because it's the one, like in a few specialty crops, they can put a price tag on that's very expensive. You send a hoeing crew into a field, you have spent a lot of money right off the bat. And we currently right now can do real-time weed detection, 10, 15 milliseconds, right? Fast enough to then hit it with a herbicide. They can hit it with a laser now. We got all those that hit it. But they're only doing object detection. They're not trying to do a whole structure for motion to understand the three-dimensionality of that plant. It's too computationally expensive. But that'll come down where we could really do that. And what there could be advantages. One of the things, if you could really do that, even on a small weed, there is enough three-dimensional architecture there that we could hit the growing point. Like even if you're using herbicide, if you could put the herbicide, like a contact herbicide, directly on the growing point there with a little dot, or you would use almost no chemistry whatsoever, but I would need to know the three-dimensionality probably to do that well. Yeah, that was a great question. Okay.
What do you think is the future troubleshooting? I mentioned putting a bunch of cameras in the tractor, right? And like, will an agricultural engineer go and fix out all these cameras, or are we all now supposed to be computer science engineers?
Well, that's a good question. I have the same question about these cars. I rode in a car the other day, so many cameras on it. No, and I think to us too as an institution, we need to be training a workforce to do a completely different thing than what the agricultural workforce is trained on right now. And you know who knows that? The farmers do. Like they are actually writing my department and they say, hey, you're not training the kids in what we see coming from the big companies right now. Why not? And it's like, well, it's a lot to get ahead of, but I think it is, very important. Now, I will say too, I've heard from several farmers, they like the fact that there's all this technology for retaining their own kids. I've had several say to me, my kids didn't want to come back to the farm. Then they got excited about drones. Now they're flying drones all over my farm. I have no idea what they're doing with the drone, but it's got them excited about farming. And so, it's it's a big mismatch right now. Sorry,
I want to build on that for scaling. Putting cameras on these combines is actually quite intensive, and it's. I was wondering what your impressions are about the readiness for satellite imagery to be used for biomass identification.
Oh, God, I have a whole, like, you want, how many volumes you want? So, no, look, the problem we have with satellites, having developed a tool that does that, is no matter what vegetation index you use, you tend to cap out after about 1,500 kilograms to 2,000 kilograms per hectare. So for a lot of cover cropping situations, that is enough, but you know, we've gotten to the where now people are pushing way up above that, and so then we run out of that. That's why we put a lot of disclaimers on our satellite version of the tool around that very issue. Now, I will say AI can be handy for that. We now use AI to study the time series of images ahead of saturation of the curve, if you will. Do you get that? And so now I at least know the high-low in the field translated into there, but I just don't know what I hit as the maximum. So there's still an angle of attack for satellites, but I'm marketing cameras right now, so I'm really trying to discourage that.
Adrian?
Oh, I think it's been answered, but maybe I will ask anyway. So I was just curious about your experience with farmers. You touched on it a little bit.
Yeah.
But as you've been building this network and putting decision support tools in their hands and asking them to collect data for you, and now thinking about them moving perhaps from these enormous machines that we see every day to maybe using autonomous vehicles. I mean, what is your learnings from working with growers through that period? And you know, what needs to change? Is it like the education of next generation that are more comfortable with these perhaps, or for us to actually trigger this big change from using where we are today to using these tools or starting to adopt robots in the field?
Yeah, that's a good question, Adrian, and I know you see a lot of this too. I would say in the last 5 years even, I've seen a lot of movement in terms, I think they're just getting hit with so many technological products now that they're diving in where there was a lot of reluctance at the beginning. They're also getting so much more aware with their questions too. Growers will now say, okay, what's happening with my data? Who gets to see it? So they're asking me about data security. I'm like, you know, when we got started, nobody asked about what happened to the data. They're like, okay, cool. So there's definitely been a big transformation in this realm. Yeah, you know, I think the older farmers, like my parents, aren't excited about it, but there's also this acknowledgement like, this is what's going to happen, so I better get on board, you know. And all of the kids I mentioned, actually, one of the funniest ones, I rolled up and the farmer said, he's like, oh, you want yield monitor maps for this field, you'll have to talk to my data guy. And so he hands me the cell phone number of his data guy. I call the data guy, and I'm like, I'm gonna need the field, I'm gonna all this for that. And he's like, yeah, there's no problem, sir, I'll send that over to you. And I'm talking to him like, God, he sounds young. I'm like, who's your data guy? He's like, it's my nephew. How old is he? He's 12. I'm like, all right, thank you very much.
Thanks again to all of our speakers. Really appreciate your time. So from here, I'm going to invite you all to come on up to our lobby. We have drinks and snacks, and we can do some networking. So thank you again for coming on out, and we'll see you. We'll start this up again in the fall. So see you then.
Oh, I didn't.